Scientific notation separates a number into a manageable coefficient and a power of 10 scale. 4.2 times 10 to the sixth represents a large value. A positive exponent moves the decimal 6 places right, producing 4,200,000. 4.2 times 10 to the negative sixth represents a very small value. A negative exponent moves the decimal 6 places left, producing 0.000042. The coefficient stays 4.2, while the exponent controls scale and direction. Predict large or small from the exponent sign before trusting a calculator display. Magnitude prediction catches many exponent entry errors. A calculator power key repeats a base according to the exponent. Evaluate 3 to the fourth power. Enter 3, press the exponent key, enter 4, and close the entry if your calculator requires it. The expression means 3 times 3 times 3 times 3. The first pair gives 9, and 9 times 9 gives 81. The calculator should display 81. 3 is the base, and 4 is the number of repeated factors. Because 3 cubed is 27, one more factor of 3 should produce 81. Confirm the base and exponent before pressing equals. A square root key reverses the operation of squaring. Find the square root of 196. Nearby perfect squares help predict the answer. 13 squared is 169, and 14 squared is 196. Enter 196 inside the calculator's square root template. The display returns 14. The principal square root of 196 is 14. The result is positive because the principal square root is the non-negative root. 14 times 14 returns 196. Estimate with perfect squares before accepting the display. A negative exponent creates a reciprocal power, not a negative result. Evaluate 10 to the negative third power. Rewrite it as 1 divided by 10 to the third power. 10 cubed is 1,000. 1 divided by 1,000 is 0.001. Therefore, 10 to the negative third equals 0.001. The answer is positive and smaller than 1. A negative power of 10 should move the decimal left by 3 places. The exponent sign controls reciprocal scale. Positive scientific notation exponent describes a number at least 1 when the coefficient is positive. Begin with 6.2 times 10 to the fifth. The exponent positive 5 means move the decimal 5 places to the right. 6.2 becomes 620,000. On a calculator, enter 6.2, use the EE or exponent entry key, then enter 5. The display may show 6.2E5 or 620,000. Both displays represent the same value. Coefficient near 6 times 100,000 should produce a value near 600,000. Use magnitude to verify the exponent direction. A negative scientific notation exponent shifts a positive coefficient to a value between 0 and 1. Use 4.8 times 10 to the negative third. The negative 3 moves the decimal 3 places left. 4.8 becomes 0.0048. Enter 4.8, press the exponent entry key, then use the negative sign key for the exponent 3. The calculator may display 4.8 e negative 3. That display equals 0.0048. The result must be positive, non-zero, and much smaller than 1. Do not confuse the subtraction key with the negative sign key. The exponent entry key represents times 10 to a power as one calculator structure. For 3.1 times 10 to the fifth, incorrect entry may type 3.1 times 10 times 5. That ordinary multiplication gives 155, far below the expected 100,000 scale. The 5 is an exponent on 10, not a factor multiplied by 10. Enter the coefficient 3.1. Press the EE or exponent entry key, then enter positive 5. The correct value is 310,000. A quick estimate near 3 times 100,000 supports the repaired display. Read E5 as times 10 to the fifth, not times 10 times 5. Predict the scale before entering the keys. Use 4 checks for powers, roots, and scientific notation. Identify the exact base, radicand, or coefficient. Predict the sign and approximate magnitude. Choose the power, root, or exponent entry key deliberately. Translate the display back into ordinary meaning. Challenge. Multiply 2.5 times 10 to the fourth by 3 times 10 to the negative second. Multiply coefficients to get 7.5 and add exponents 4 plus negative 2 to get 2. 7.5 times 10 squared equals 750. Key choice, exponent sign, and magnitude check should all agree.